Hi to all, I am Shravanti and today I am going to tell about basic introduction about BEE, Basic Electrical Engineering. This is the common subject for all other branches like CSE, Data Science, AIML, and it is very useful for all those people. Now I am starting first unit. So actually in BEE it is having 5 units. In that first unit is DC circuits. Second unit is AC circuit. Third one, transformers. Fourth one, electrical machines. Fifth one, electrical installation. Okay, these are very basic introduction informative topics. Those are included in all 5 units. In that, first of all, I am focusing on important topics. So in that first one, DC circuits. So in DC circuit, what do you mean by DC? DC is nothing but direct current. Circuit is nothing but it is having the combination of active as well as passive elements. So it is a closed circuit. Circuit is nothing but it is a closed path having passive as well as active elements. Now coming to AC circuits. Here I am applying only DC and observe the output of voltage, current, power based on the timing or based on the values of applied voltage. Now coming to AC circuits, in this AC circuits we are giving input as AC, alternating current. Okay, it should be based on the magnitude as well as direction, but DC having a constant magnitude here. And coming to third unit, here transformers. So in transformers, how many types of transformers, what is the basic construction working principle, these are included in the transformers. And coming to electrical machines. So in this electrical machines, totally it is subdivided into two parts. One is AC as well as DC. Just basic information, that is operation, working principle, construction of all AC as well as DC machines are included in this unit, that is electrical machines. Now coming to electrical installation, how to give an installation for industrial applications as well as home applications. Those are small switch fused unit, MCBs, ELCB, circuit breakers, earthing. Okay, these all are the basic informative topics are included in the electrical installation. Okay, now coming to first unit, that is DC circuits. So in this DC circuits we are having totally 5 important topics. In that first one is KVL and KCL. Kirchhoff laws, call it as Kirchhoff laws. And coming to second one, basic series and parallel circuits. In this series and parallel circuit, we need to find out the equivalent resistance, equivalent capacitance, equivalent inductance. Now coming to third one, here based on these, the disadvantages of these two are included in the theorems. And nodal, fourth one, nodal and mesh analysis. And fifth one, it is DC excitation. Okay, for series circuits we can apply DC with respect to time. Okay, so these are the main topics which are very important for final semester exams. So here I am, first of all I am discussing about the basic circuit. What do you mean by circuit? So circuit is a combination of active and passive elements. So it is one circuit, a simple circuit I am considering. So this is the source I am applying V, amount of voltage. So here this supply, call it as active element, and remaining elements are passive elements. So here resistor, inductor, capacitor, and these three are the passive elements, and V is nothing but active element. So here, based on the circuit elements, we can form different circuits or networks. Okay, so now coming to circuit elements. So circuit is nothing but a closed path which is having active as well as passive elements. Now coming to basic elements, classification of elements. So here in this circuit, it is having active as well as passive. So now what do you mean by active? So active elements. Active elements. So active element is nothing but which can provides the supply to the circuit. So suppose I am considering one simple circuit here, resistor, inductor and capacitor I am considering, and here I am applying some amount of source. So here the source act as active element, means which can give the supply to the circuit. Okay, so what are the examples of active elements? Here I am considering voltage source or current source. These are the theoretical considerations. Coming to practical way, we can consider battery as well as generator. So now those are active elements. Active elements means which can delivers the supply to the circuit. Okay, those are voltage source and current source. Now coming to passive elements. Passive elements. Passive elements. So these are the elements which can absorb the energy from the supply, which can absorb the energy from the source. Those are nothing but active elements. So these elements, passive elements, are absorb the energy or absorb the supply from the active elements. So what are the examples of passive elements? Means here resistor, inductor and capacitor. These three are the passive elements. These three are absorbing the energy. Now coming to individual element, here I am considering resistor. Okay, so this resistor is nothing but it is an element, not a property. So now it is an element, it is denoted with this symbol. Okay, and what is the unit of resistance? Here resistor, it is element, and I am considering resistance. So resistance is nothing but a property of resistor which always opposes the flow of current, which always opposes the flow of current. So now according to passive element, so resistor, which it is a passive element which absorb the supply and deliver it in the form of heat. Deliver it in the form of heat. Now coming to inductor. So inductor is also a passive element. It is also absorb the energy, but it should be stores the energy in the form of electromagnetic field. It stores the energy in the form of electromagnetic field. Now coming to last element, that is capacitor. So capacitor is also a absorbing element, and then absorbed element energy should be stores in the form of electrostatic field. Electrostatic field. So resistor, inductor, capacitor, these three are the passive elements which are basically absorb the supply from the active elements. And coming to the property, individual property of each element, they can dissipate or otherwise they can store in the form of electromagnetic field or electrostatic field. Okay, so these are the elements. These are nothing but passive elements. Now coming to individual elements. So here resistor, inductor, capacitor are the passive elements. Voltage source, current source, generator and battery, those are the examples of active elements. Now coming to individual elements. So here I am considering passive elements first. So in final semester last in external exam they need to ask about explain active and passive elements. So explain active and passive elements means example for passive element are nothing but we are considering resistor, inductor, capacitor. Coming to active element we can consider voltage source, current source, battery, generator, real time applications. Now coming to individual element. So here I am considering passive elements, passive elements. Okay, so what are the passive elements? Resistor, inductor and capacitor. Resistor, inductor and capacitor. Now coming to individual element. So here I am considering resistor. So resistor is denoted with the R letter and the symbol of resistor is, this is the symbol of resistor. Okay, and it is measured in terms of ohm. It is measured in terms of ohm. Okay, now how it will it is a passive element which always oppose the flow of current. Now it is having some property that is nothing but resistance. Resistance is a property of a resistor. It is also denoted with R letter, so it always opposes the flow of current. The property of a resistor which always opposes the flow of current. Now what do you mean by current? So current is nothing but flow of electrons. Quality means Q is nothing but charge per time. Okay, so what is the unit of current? Coulomb per second, or call it as ampere. Okay, so always a resistor which always opposes the flow of current. Now this is nothing but current. Current is nothing but it is the ratio of charge to the time. Charge per unit time. The unit of charge is coulomb, time is second. So 1 coulomb per 1 second gives 1 ampere of current. Okay, so now a resistor which always opposes the flow of current. Now coming to the property of a resistor. So here this resistor should be depends upon the conductor length. It is R is directly proportional to L by A. Okay, so L is nothing but length, A is nothing but cross sectional area. Okay, cross sectional area. Okay, so now the resistance of a material, it should be based upon the length of the conductor and area of cross section of that conductor. It is inversely proportional to the cross sectional area of the conductor and it is directly proportional to the length of the conductor. So we'll get one proportionality constant here, that is R equals to rho L by A. Okay, so rho is nothing but what? Resistivity. It is also a resistive property. So from this we can consider rho equals to R into A by L. Now what is the unit of resistivity? Based on the values of resistor, inductor and resistor, cross sectional area and the length. So resistor, what is the unit of resistor? Ohm. And what is the unit of cross sectional area? Meter into meter, meter square, length into breadth. Now L is nothing but length measured in terms of meter. So meter get cancelled. Rho equals to ohm meter is the unit of resistivity. Okay, so resistivity is also a property of resistor. Okay, so now resistor which is depends upon the two, one is length of the conductor, another one is area of cross section. Now coming to, before going to this topic, first of all we need to consider Ohm's law. That is the basic Ohm's law. So Ohm's law is nothing but here at a constant temperature is maintained constant here. At a constant temperature, the potential difference between two ends of a pure metallic conductor. This is a pure metallic conductor. Okay, so the potential difference between a pure metallic conductor is directly proportional to the current passing through it. So here I am applying some voltage to a pure metallic conductor. It is having two ends. Okay, at a constant temperature, the potential difference between two ends of a pure metallic conductor is directly proportional to the current passing through it. Okay, based on this Ohm's law, V is directly proportional to I, then we'll get the proportionality constant R into I. So R is nothing but resistance. R is nothing but resistance. Okay, so Ohm's law, what is the statement of Ohm's law? At a constant temperature, the potential difference between means applied voltage. The potential difference between two ends of a pure metallic conductor is directly proportional to the current passing through it. Okay, so based on this Ohm's law, we get a resistor here, resistance here. Here V is nothing but voltage measured in terms of volts, I is nothing but current measured in terms of ampere, and R is nothing but resistance measured in terms of ohm. Okay, so after completion of Ohm's law, we can consider different types of active elements as well as passive elements. Now, this is a resistor. So, resistor having resistive property. Okay, now resistance completed. Now coming to inductor. So here inductor is also a passive element which is always absorb the energy from the source and they are stores in the form of electromagnetic field. Okay, so here a twisting conductor, I am considering inductor element. So inductor element, how it can form based on the conductor. A twisting conductor form inductive property. Okay, a twisting conductor gives an electromotive means inductive property. When I am applying some energy, some supply to this inductor, it produces some amount of self-induced flux. So according to Faraday's laws, here the flux induced means we are applying voltage V. So V is directly proportional to d pi by dt. So V is equals to N into d pi by dt. So N is nothing but number of turns. So here we are considering voltage. So according to Faraday's laws, based on the Faraday's laws, it exhibits inductive property. So here the applied voltage is V. Okay, now this V is equals to L into di by dt. According to Faraday's laws, we can write it as V equal to L into di by dt. So I is nothing but current, change in current. So here inductor is nothing but element. Now it is having one property, that is inductance. It is also denoted with L letter. So what is the function of what is the property of inductance? It should be okay, an inductance, the property of an inductor which always opposes the sudden change in current. It always opposes the sudden change in current. And what is the unit of inductor, ma? So here I am considering Henry. So Henry is the unit of inductor. So we can consider it as millihenry, microhenry. So what do you mean by small m? 10 power minus 3 Henry. Micro means 10 power minus 6 Henry. We can measure inductance in the form of millihenries, microhenries. The basic unit of inductance is Henry. Now coming to, this is the inductive property, inductor. Now coming to capacitive property, means capacitor. So capacitor, it stores the energy in the form of electrostatic field, electrostatic field, and the capacitor property is capacitance, capacitance. Okay, it is denoted with C letter, and the capacitor symbol is two parallel plates, two parallel conducting plates, conductors. Okay, those are separated with a medium of dielectric, dielectric. Okay, now this is positive polarity, this is negative polarity. A two parallel plates are separated with an dielectric medium. So what is the dielectric medium? Here I am considering mica or impregnated paper or chalk dust. These all are comes under dielectric media. Okay, so now here this is the symbol of capacitor, and the unit of capacitor is farads. It is denoted with the F symbol. It is also measured in terms of microfarad, millifarad, like that. Okay, so basic unit is farad. Okay, now capacitance. When I am applying some voltage to this capacitor. Okay, now the charged particles are moves from positive to negative based on the dielectric medium. Then it passes current, electricity. Okay, so now according to capacitive property, it always opposes the sudden change in voltage. So it is always opposes the sudden change in voltage. Now what is the formula for capacitor? Here I am considering C, capacitance, that is nothing but Q by V. Okay, so Q is nothing but charge, V is nothing but applied voltage, C is the capacitance. So now here Q is nothing but charge measured in terms of coulombs, V is nothing but volts, voltage. So 1 coulomb per 1 volt gives 1 farad of capacitance. Okay, so now it always C equals to, we can write it as here the current I equals to C into dV by dt. So it always opposes the sudden change in voltage. I is nothing but current, V is nothing but voltage, C is nothing but capacitance. Okay, so the property of capacitance is which always opposes the sudden change in voltage. What is the property of an inductor? Which always opposes the sudden change in current. And this L and C are the both are storing elements, and in resistor is dissipating element. Okay, so thank you for watching.